All right, so I'll introduce Dr. Thoma. Greg Thoma is a professor and director of agricultural modeling and life cycle assessment with AgNext at Colorado State University, specializing in sustainable beef production and environmental impacts. With expertise in life cycle assessment, his work focuses on evaluating the greenhouse gas emissions and resource use associated with beef production. Greg's research aims to identify pathways for reducing environmental footprints and advancing climate neutrality in the beef industry. So please join me in welcoming Greg.
Thanks, Sam, and I'd like to thank the organizers for inviting me here today. I have only 2 slides, so I'll be brief in my introduction, and hopefully we'll have some time for discussion. This is the high-level results of probably the most recent national-scale life cycle assessment done for the beef sector in the U.S. We do have a laser pointer. The greenhouse gas emissions up here in this upper quadrant, we can see the various sources, and the most important thing here, which is not a surprise because we've heard it already today, is that the cow-calf sector is the largest contributor to greenhouse gas emissions in the U.S. beef sector. The pie chart over here shows us that enteric methane contributes 55 or 60%, but that nitrous oxide is a non-trivial additional contributor that we should think about, as I think Frank mentioned in his talk last night, about thinking in terms of not only the greenhouse gases, but also reactive nitrogen. So they're very important factors to consider. So the basis for the data shown in this slide is a life cycle assessment, which is a systems perspective that takes material and energy flows, tries to calculate all of the things that happen, all of the activities, and do an accounting. Sorry about that. I had in my mind, turn on the do not disturb, but that was 15 minutes ago. So these systems are, of course, very complex, as all of the presentations already today and yesterday have elucidated. They're difficult to measure. They're complex not only because there are large numbers of them spread out across multiple geographies, multiple soil types, multiple management systems. So trying to measure these really complicated things, not only because of all of the different measurement technologies that was discussed a couple of presentations ago, the lasers and the green feeds, et cetera, right? All of those things with all of their uncertainties add tremendously to the challenges of how do we just keep track of these things on an individual farm, much less at national scale. And so when we think about all of the biophysical and other complicating factors that make it difficult to measure, then we have to add the entire accounting scheme, right? So if we're talking about climate neutrality, we have to have a way to measure whether we're moving in the right direction. And there are 2 things that I think are really important in this context. One is that the adage, we manage what we measure, is very true, right? If we're not taking measurements of these things, we're never going to manage them. But equally importantly, perhaps more importantly, it matters how you measure. And all of the things that we've seen already today underscore this. So this next slide is a summary of some of the indicators, right? The things that we want to measure and the complexities that get layered onto all of the experimental work that we do to make the physical measurements. We've got GWP 100, some GTP, we've got GWP star and cumulative GWP star. So the first 2, GWP 120, are based on pulse emissions. They don't do a very good job of representing the behavior of short-lived climate pollutants, particularly methane, right? So if we use that as our accounting metric, that's got some serious shortcomings, right? I think we all understand that. GWP 20 is similar, right? It's a pulse emission, but only over 20 years. And it may overemphasize the contribution of the short-lived gases, so that's problematic. The GTP class of indicators are all also based on a pulse emission of a climate pollutant with a certain time frame, GTP 20, 50, 100, whatever, and they are an attempt to measure the temperature impact as opposed to the radiative forcing of the GWP 100 in a certain time frame. Better for policy because, right, if we think about the Paris Climate Accord, it's got a temperature target. And so meeting that temperature target might make sense to think about GTP. But again, they don't do a very good job with the short-lived climate pollutants. So GWP star, probably many of you have heard of it or tried to use it. It's highly volatile. It's very, very sensitive on a year-by-year basis to the number of animals in the herd or to other things that may change the methane emissions. The cumulative GWP star is a pretty good approximation of warming potential and might be one that we could consider. However, both of those are not pulse-based, they're emissions-based, and you have to have a long-running data set, typically 20 years of data, in order to do the calculations on these. So we manage what we measure, and it matters how we measure it. And in particular, with regard to progress towards climate neutrality, we need to keep these things in mind. And I hope you have some good questions about how we move forward with this sort of messy place that we find ourselves. Thank you.